So in equation, oftentimes students get a little confused about expressions and equations. Okay, so if you have something like this, right? If you have an equal sign, and say you got, let's just do it this way. Say, for example, you have y equal to x squared plus 4x plus 9. Right, this thing here. If I'm just talking about this one and look at this without equal sign, this is what we talk about, typically call expression. Right? So in a problem, like in a textbook, you will have a question to say, hey, simplify expressions, combine like terms, and do this and do that to this expression. And that's what they're saying. It's like they're taking this little piece, this chunk out, and you kind of manipulate them. That's what you need to do. And on this side, right, even though it's just a y by itself, it is still called an expression. Of course, when you put them all together with an equal sign, this is called the equation. But if it's equation that gets mapped onto visually on the graph, x and y graph, if equation gets mapped into the graph, this one we can also call function. That's it. This is really the basic definition. I want to make sure that you have clarity on all these terms. No, it's really simple. Let's not make it too confusing. Textbooks have all these different things and whatever. I'm distilling them into the real essential. That's it. That's it. So when you see an example and say factor the expression x squared plus 4x plus 4. Okay? Notice there's no equal sign. So this is an expression. So I have to really make sure I follow the rule of expression, because equal sign, you can do things on two sides of the equation. When you have an expression, you can't really do anything about that, right? So you can only do what's within the confine of this. So if I do this, right, you have x squared plus 4x plus 4. Go ahead and factor this. I'll give you 1 minute, and I'm going to come around and see what you do. Simple questions. I'm sure most of you probably know how to do this. I just want to make sure that you should correct it. How do you factor this? Basically, it's making it into something times something, right? When you say factor, it's like something times something. And so I can basically say, how can I turn this? This basically has three things: x squared plus 4x plus 4. So it's 1, 2, 3. They're separated by plus and minuses. But when you multiply, when things get multiplied or divided, you can lump them as one. So how can I turn this expression into a one thing? That's only separated, well, not separated, but joined by multiplication. What do we have? You got it? You got it? You got it? Right. What happened? All right, so many of you have this, right? You say, okay, we'll factor these two things out and say, what are the two terms that when they multiply, we'll get back to this. Now notice I didn't put equal sign. At best, you will see the way I write the solution will be, I'll put a little arrow. Because I know that this is talking about expression. If I'm talking about equation, I will follow very carefully the equal sign. This is the arrow. And you say, okay, this one, maybe we can do this. Right? X plus 2 times x plus 2, boom. You know, and some of you may take it even further and say, oh, these are two of the same thing, so I can turn that into x plus 2 squared. Right? Another way to think about this is a different way, and you may or may not have learned how to do this. I don't know. Maybe you already did that. Maybe I'm doing something too simple for you. So if you have x squared plus 4x plus 4, and you may struggle to figure out what are the terms on these. What you can do is you can assume that this is 1, right? So you have 1 here, 4 here, and 4 here. So I ask myself, what are the two numbers that can be factored out of 1?
1 and 1.
That's right, 1 and 1. So I put it like this, 1 and 1 vertically. What are the two numbers that I can multiply into 4? 2 and 2, 4 and 1, right? The two options, 4 and 1 and 2 and 2. Let's just for the sake of argument, I'm going to do a way that doesn't work, but you'll see the process. I say, okay, if I say 1 and 4 multiply into 4, then I will put 1 and 4, 4 and 1, doesn't really matter which direction. What you can do is you take this number and you put an arrow that way, you take this number, you put an arrow that way, you draw a line underneath, and you say, okay, 4 times 1 is equal to 4, 1 times 1 is equal to 1, add them together, this is equal to 5. Does it equal to this number?
No.
No, it doesn't. However, if I change this, if I change these two numbers to 2 and 2, right? 2 times 1 is equal to 2, 1 times 2 is equal to 2, 2 plus 2 is equal to 4, and this 4 is this. Aha, I had a good combination. So I'm using this one and this one. So I have 1 and 2, 1 and 2, plus, the first term is with the x. So x plus 2 times x plus 2. You can do any factoring if they have the complete square, if they have the good solid factors, you can use this method for anything.
Even if, say, x is 2, so it's 2x, we could use something like that?
Yeah. Yeah, so I'll give you an example. I'll give you one example like this. Actually, let me do an application on this. Okay. Now, solve equation. Solve equation. If I have x squared plus 4x plus 9 is equal to 5. How do I solve this equation using the method of factoring? Yeah.
Well, you would want to make it a factor, so you would want to subtract 5 from both sides. So you get 4x to x is 7 power plus 4x plus 4.
Yeah. So very, very true. Similar to this, right? Similar to this, we want to make this as simple as possible, right? Equation. When you have an equation like this, you want to make sure that you want to at least make one side of the equation as simple as possible. There's no other way than making one side of the equation 0. Right? So you turn the other side of the equation equal to 0. X squared plus 4x equal to 9 minus 9. Right?
Wait, so why did you take the 9? Why not?
Oh, I'm sorry. We should do it this way. We want to turn this, bring it over here. 9 minus 5. Yeah, you're right. Right? So now, you turn this into this, and you end up with x squared plus 4x plus 4 is equal to 0. Hey, this is the equation. Notice my equal signs all lined up, right? So I'm very, very systematic. But now you can see that on one side of the expression, it goes back to what we've done earlier. The reason why we learned this is so that we can use this on this, right? So all of a sudden I say, okay, now I can factor this out. I can say this is x plus 2 equals to 0. Well, if you have x plus 2, or you have something times something equal to 0, you can set x plus 2 equal to 0, x plus 2 equal to 0, right? Separate them out. Now since they're the same, I only need to solve for 1, so x is equal to -2. So I'm using this process on the equation. Make sense? Now notice, this is what I call the solution steps. And this is the answer. I want to tell you right now that in this course, this portion, the solution steps, is probably more important than your final answer. If I give you a problem like this, obviously I'm going to give you a more complicated problem on the test. But say, presumably, if I give you a problem like this, and this is worth 5 points, and you don't show any of this, and you come up with the right answer, you only get 1 point. If you somehow do this problem and you end up with the wrong answer because you messed up on this step, you may get 3 points. And if because if your logic is sound, you may get 3 points or 2 points out of the 5. Yeah. What's that? Yeah. You can jump ahead. I mean, that's really obviously this problem is much simpler, right? So this you can actually do a lot of shortcuts. The problem that you see on the test will be more 5 steps. Okay, so it will require a lot more complex steps.
Does it matter how we show a roll? Does it matter how we show a roll? Or is it like...
No, it doesn't matter. No, because there are different techniques for problems like this, right? So this is just I'm just showing an application of factors in a quadratic equation process. You can later on, when you do quadratic formula, you can do that. You can do it all sorts of different ways. Okay? All right, now, moving on. Let me move this over here. Have you done completing squares? How many of you have done complete squares? Okay, you just 2. So here's a simple one, right? We know that if we take a plus b squared, this expression here, and this may jog some of your memories back in Algebra 1, is that you can say this is a plus b times a plus b, and then you do factor, you do the FOIL, right? You do FOIL. Then you're gonna end up with a squared plus 2ab plus b squared. You have to memorize this, okay? Because it will be a shortcut. So a plus b squared is equal to a squared plus 2ab plus b squared. Okay. So I'm going to utilize that to my advantage. I'm going to take this portion, knowing that if I can turn any of these expressions to be able to match up to this, I'm able to complete square. Does that make sense? So in this case, I'll give you an example. I want to solve an equation that says x squared plus 4x minus 8 equal to 0. And I want to be able to use complete square methods. This one, you will notice, if I use this thing here, it doesn't come out nicely. It's really hard. Right? If I say, don't write this part, I'm just showing you this part. Right? I say this is one, so you got 1, 1, this is 4 and 2, maybe one of them this way. There's a bunch of different ways of doing this, right? So we get negative 2 times 1 is negative 2, 1 times 4 is 4, right? So this one gets, you end up with 2, doesn't match with a 4. I can try different combination of factors, doesn't work, okay? I have enough experience to know that this problem is not going to come out nicely. So I had to come up with a different strategy. You see, sometimes certain strategies we teach you, it's just one of the tools in the toolbox. This tool doesn't work. So guys, go somewhere else. So I'm going to use something different. So this is where you have to say, okay, we can't do what we do over here, like this. You see, over here, we move the phi to this side. You notice? This one, since I'm abandoning this method, then what I do is do the opposite thing. I'm going to move this thing to the other side. Okay? Over here, notice, we set the quadratic expression and set that equal to 0. This one is already equal to 0, and it doesn't work, so I had to do something different. I'm going to turn this x squared plus 4x and then set it equal to 8. Notice I leave some space here. Now I notice that this is 1 right here, this is 4, right? So in this case, we have the A will become, so in the case here, let me see if I can map it out here. Let me map it out. A squared plus 2ab plus b squared is equal to a plus b squared. Now what I have right now is x squared plus 4x plus unknown equal to something squared we don't know. So I notice that my a must be x, right? A and x. Makes sense. So if a is x, this a maps with this x, then that means, what does that mean?
This is 2x times 2x, or 2x.
No. I only care about what's left out. So if a is x, what's left out is 4 right here, and then 2 times b, right? You notice that? So that means 4 is equal to 2b. Yeah? Then what's b? Then what's b? If 4 is equal to 2b, then what's b? 2. b is equal to 2. Oh my goodness. So if b is equal to 2, that means I can put this number, right? If b equal to 2, then this is 2 squared, right? Because b is 2. We just found 2. So over here, then we will have x plus 2 squared, right? A is x, b is equal to 2. So this is what I will do. I'll put right here, 2 squared, right? But if I do one thing on one side of the equation, which is plus 2 squared, I must do exactly the same thing on the other side of the equation. Yeah? We learned that in Algebra 1, 2 squared. So you got to do the same thing on both sides. So what does this mean? That means that you end up with, you can say this is a plus b squared now. So x plus 2 squared is equal to 8 plus 4, which is 12. Okay? So you got this whole thing squared is equal to 12. You say, okay, well you have a square. Square is locking everything up in that expression. to get rid of the key to get rid of that lock to the square is square root, right? But if you square root on one side of the equation, you must square root on the other side of the equation. Who can tell me what I'm missing right now? When I do square root on both sides of the equation, what am I missing? If I have, let me ask you this. If I have, say, x squared is equal to 4. Like, for example, this is a side conversation, right? The side conversation says x squared equal to 4. Then what's x? 2 and negative 2. Right? Isn't it x equal to 2 and negative 2? Because negative 2 squared is also going to give you 4, right? So whenever you're squaring root on both sides, you have to have a positive and a negative. So this is what you end up. You end up with x plus 2 is equal to plus minus square root of 12. So what's your answer? X plus 2 is equal to square root of 12. And x plus 2 equal to negative square root of 12. Right? Boom, 2 answers. And guess what? Solving quadratic equations, because it's power 2, you usually will have 2 answers. 2 answers. And do you know why quadratic equations usually have 2 answers?
Because it's the same power, so that can be positive 1 of it, and we still have the same value.
Sure. That's one explanation. Good verbal explanation. How do you visualize it? So remember, quadratic equation is basically a parabola, right? Say parabola like this. This is x and y axis. And we say, oh, if we want, say for example, we want this equal to 4, the quadratic equation, the function, will hit this point as a solution, and then this point as the same solution. That's going to give you the same answer. Right? So any quadratic equation is a parabola, and when you're solving an equation, you're basically saying draw a straight line, plus. Boom, it will hit 2 points. When you hit 2 points, that's 2 answers. Is it possible for quadratic to have only 1 answer?
No.
Think through it. A quadratic, you draw a straight line, boom. Is it possible to get 1 answer? Probably. Where? Quadratic like this, draw a straight line, hitting where? At the vertex. If you hit at the vertex, you only get 1 point. Then your answer, you're only going to get 1 answer. Is it possible that your quadratic gets no answer?
If it's below the vertex, yes.
That's right. It may be that boom goes down here. And guess what? This is going to give you complex answers. Complex answers going to give you imaginary numbers, which we may be able to get into today. Okay? So, let's finish this up. Let me finish this up. So, your final answer is x is equal to negative 2 plus square root of 12. X is equal to negative 2 minus square root of 12. Those are your 2 answers. And you can leave your answers like that.
Okay, so x is equal to negative 2 and negative square root of 12, and then x is equal to negative 2 plus
square root of 12. Now, you can simplify square root of 12 if I ask you to. You don't have to, right? Square root of 12 is 4 times 3, right? Inside 4 times 3, but 4, square root of 4 can be taken out, so square root of 2 will be 2 square root of 3. Right? Make sense? You do that in your head? Can you see it? Okay. Now, so let me break this down a little bit simpler. Shortcut. When you have something like, let's talk a little bit about this, right? So this is our solution steps, and this is our answer. Now, when we want to complete square, completing square, what you can do is you clear out your equation. You clear out the one that only has a number, right? So you see, you move this to the other side. So you end up with these two things, x squared plus 4x. Very simple. You take that number, right? That number that represents, right? That goes with the x term. You take that number, divide by 2. It will be this one, and then square. Take this number, divide by 2, which is 2, right? 4 divided by 2 is 2. 2 squared is 4, so you put 4 here. If you put 4 here on this side, you put 4 here on the other side. You put 4 on the other side. That's it. And why is it that I'm justified to take this number and divide by 2 and square that? It's because of this. I just showed you here. That's the explanation.